Today's question from Reddit comes from an algebra type question, and it's on like terms. In our poster, they already went to the back of the book, they saw that the answer is A and C, and they're just unsure how they go about getting there. Before we get straight into the problem, I just want to do a refresher on what like terms are. And they're algebraic expressions that have the same variables raised to a certain power. So if I were to say 5x to the third and 2x to the third, well, with these two, we can do addition or subtraction on them, and we'll get a new answer. We'll get 7x to the third. However, in the same sense, if I did 5x to the fifth plus 2x to the third, if I told you to equal what that is, well, because they're different, they're not like terms in that sense, you're just going to end up with the exact same thing. There's no way to combine these two, so you'll just end up with the same thing again. So that's the whole point of why we do this exercise. Because we were simply asked to find like terms and not actually do any operations on them, well, we can start off already by looking at this 6, this -2, 2, and 6. And because they're all coefficients, we actually don't need any of them. So we can go ahead and eliminate all of them. And there we go. And that already cleans up our problem a little bit. Alright, lastly what we'll need, in the case where we have these negative numbers, we need to know how to handle them. So, for instance, x to some negative n number is always going to be able to be written as 1 over x to that n number. And that's how we'll go about handling this. So if I said x to the negative third, well, that would be equal to 1 over x to the third. Cool? Cool. There's also the product rule, which I won't go and define here, but I won't go into the details of proving here, but similarly, it's x to some a times x to some b is going to be equal to x of a plus b. So in this case, if we said like a was 2 and b was 3, well then we'd have x2 times 3 is equal to the same thing as x to 2 plus 3. Or also x to the fifth. Alright, so let's start simplifying these out. And for our first example, we know that x cubed can also be written as x times x times x. We'll multiply by that y, and then we're going to actually divide by 1x because we have an x to the negative power. And there we go. What we can cross out here is this 1x up here, and we'll eliminate the x down below. And we're simply left with x squared times y. In our next example, we'll go ahead and use the product rule for this one, which is our a in this case is going to be that 3, and our b is going to be the -2, and we'll multiply that by y, and we're going to be left with just a singular x and a y. And for our last example, you can do what you want. On this case, I'm just going to do the whole division that I've done up on top. We'll have 2 x's above an x times 3 y's divided by y. This will cancel out. This x will cancel out with that one. And we'll be simply left with x times y squared. Fair enough, no tricks up my sleeve. And now that we're looking at like terms, we'll just box our results from each one of these. So in our first example, we have xy. In our second example, we've got x squared times y. Third, we've got xy. And our fourth one, we've got x times y squared. As you can see, this first term and this third term both share that xy in common. So those are our like terms. Whereas our second term has an x squared, which no other term has that. Similarly, our fourth result has y squared, which doesn't share in common with any of the other terms that we found. If you found this helpful, drop a like, leave a comment, and don't worry, the market videos are coming. There's just been a little too much going on in the world right now.